Welcome, space enthusiasts, to what might be the most important astronomical discovery of 2025. I'm talking about Comet 3I Atlas, the third confirmed interstellar visitor to our solar system, and quite possibly the most mysterious object we've ever encountered in space. But here's where things get really interesting. Just days ago, a bombshell paper from Harvard's own Dr. Avi Loeb dropped into the scientific community like a meteor strike. The revelation, this interstellar visitor is not what we thought it was, not even close. The numbers coming in are so staggering, so utterly mind-bending, that they're forcing us to reconsider everything we thought we knew about interstellar objects. 33 billion tons. Let me say that again, for those in the back. 33 billion tons. That's the minimum estimated mass of this cosmic visitor, and if that number doesn't immediately strike you as absolutely insane, let me put it in perspective for you. Imagine taking every single car on Earth, all 1.4 billion of them, and stacking them together. You still wouldn't even come close to the mass we're talking about. Picture the Great Pyramid of Giza, one of the most massive structures ever built by human hands. You'd need to stack over 5,000 of them just to equal the mass of this single object hurtling through our solar system. The Eiffel Tower, you'd need 3 million of them. 3 million Eiffel Towers worth of mass, compressed into a single object that's screaming through space at velocities that make our fastest spacecraft look like they're standing still. But mass is just the beginning of this story. What we're about to explore over the next 20 minutes will challenge your understanding of what's possible in our universe. We're going to dive deep into the data, examine the anomalies that have scientists scratching their heads, and yes, we're going to address the elephant in the room, the possibility, however remote, that what we're looking at isn't entirely natural. Now, before you click away thinking this is just another sensationalist space video, let me be crystal clear about something. Everything I'm about to share with you comes from peer-reviewed papers, respected scientific institutions, and data from the world's most advanced telescopes. We're talking about observations from the James Webb Space Telescope, the Gemini Observatory, and ground-based arrays that represent billions of dollars in scientific investment. This isn't speculation run wild. This is science at the bleeding edge, where observation meets the limits of our understanding, and where even the most conservative scientists are being forced to admit something very, very strange is happening here. The discovery that changed everything. Let's rewind the clock to July 1st, 2025. It's a clear night in the Atacama Desert of Chile, one of the driest and most pristine observation sites on planet Earth. The Atlas telescope, that's the asteroid. Terrestrial impact. Last alert system, for those keeping track, is doing what it does best, scanning the heavens for potentially dangerous objects that might threaten our planet. Atlas is like Earth's cosmic security system. Every night, it photographs huge swathes of the sky, comparing images to spot anything that moves against the background stars. Usually, it finds asteroids, chunks of rock and metal left over from our solar system's formation. Sometimes it spots comets, dirty snowballs from the outer reaches of our cosmic neighborhood. But on this particular night, Atlas spotted something that immediately set off alarm bells in the astronomical community. The object appeared as a faint smudge, barely visible even to Atlas's sensitive cameras. But it wasn't the object's appearance that caught astronomers' attention. It was how it was moving. You see, every object in our solar system, from the smallest grain of dust to the largest planet, follows predictable paths governed by the sun's gravity. These paths are elliptical, closed loops that keep objects bound to our star. But this object, its trajectory was hyperbolic, an open-ended path that could mean only one thing. This object wasn't from around here. It was an interstellar visitor, a cosmic wanderer that had traveled across the unimaginable gulfs between stars to reach our solar system. Within hours of the discovery, every major telescope on Earth that could see it was pivoting to focus on this mysterious visitor. The astronomical community operates on a principle of rapid response when it comes to transient objects. Things that appear suddenly and might not stick around for long, and boy did they mobilize fast. The initial designation was clinical, almost mundane. C2025N1. But as orbital calculations confirmed its interstellar origin, it received a new name that would soon be on the lips of scientists worldwide: 3I Atlas. The 3I designation marking it as only the third confirmed interstellar object ever detected passing through our solar system. Let that sink in for a moment. In all of human history, with all our telescopes and all our observations, we've only confirmed 3 objects that definitely came from another star system. The first was Oumuamua in 2017, that bizarre, cigar-shaped object that spawned 1,000 theories and controversies. The second was Borisov in 2019, a more conventional-looking comet that at least behaved somewhat like we expected an interstellar comet to behave. And now, 3I Atlas. But if astronomers thought they were getting another Borisov, a relatively normal comet just happening to visit from another star, they were in for the surprise of their careers. The first signs of strangeness. The initial observations seemed promising enough. Unlike Oumuamua, which was only spotted as it was already leaving our solar system, 3I Atlas was caught on approach. This meant astronomers would have months to study it as it swung around the Sun, gathering unprecedented data on an interstellar visitor. Dr. Sarah Chen from the California Institute of Technology was one of the first to analyze the spectroscopic data. I want you to imagine her surprise when the results came back. Speaking to colleagues at a hastily assembled virtual conference, just days after the discovery, she reportedly said, "Either our instruments are all malfunctioning in exactly the same way, or we're looking at something unprecedented." What did she mean? Well, when you point a spectrograph at a comet, you expect to see certain signatures. Water ice, for instance, produces very specific spectral lines. It's like a cosmic fingerprint, unmistakable and universal. Methane, ammonia, carbon dioxide, all the usual suspects in a comet's composition have their own unique signatures. But 3I Atlas, it was showing a composition unlike any comet in our solar system's database of over 4,000 observed comets. The most striking anomaly? An almost complete absence of water ice signatures, replaced by an overwhelming presence of carbon dioxide. Now, you might be thinking, so what? It's got different ice. Big deal. But here's why this matters. Water ice is the fundamental building block of comets as we understand them. It's so common in our solar system's comets that we literally call them dirty snowballs. Finding a comet without significant water ice is like finding a beach without sand. Technically possible, but so unusual that it immediately raises questions. The carbon dioxide signature was strong, incredibly strong. Initial estimates suggested the object was outgassing CO2 at a rate of about 70 kilograms per second. That's about 154 pounds of frozen carbon dioxide sublimating into space every single second. For comparison, that's like having a block of dry ice the size of 2 refrigerators completely vanishing into gas every second. But the spectroscopic anomalies were just the appetizer. The main course of weirdness was about to be served. When the impossible becomes observable. July rolled into August 2025, more powerful telescopes joined the observation campaign. The Gemini North Telescope in Hawaii, with its 8.1-meter mirror, captured some of the highest resolution images yet. The James Webb Space Telescope, humanity's premier infrared observatory, managed to squeeze in observation time between its other commitments. Even the venerable Hubble Space Telescope, over 3 decades old, but still producing cutting-edge science, turned its eye toward our mysterious visitor. What they saw defied easy explanation. First, there was the color. Most comets, when they start outgassing near the Sun, develop a greenish hue from diatomic carbon, C2 molecules, fluorescing in sunlight. It's such a common phenomenon that amateur astronomers often call active comets green fuzzies. But 3I Atlas glowed with a distinct reddish tinge, more reminiscent of certain outer solar system objects than typical comets. Dr. Michael Thompson from the European Southern Observatory described it in a press briefing. The reddish coloration could indicate complex organic molecules on the surface, materials that have been processed by cosmic rays over millions or billions of years. Or it could be something else entirely. We're literally writing the textbook as we observe. Then there was the shape of the coma, the cloud of gas and dust surrounding the comet's nucleus. Normally, A comet's coma is roughly spherical or slightly elongated in the direction away from the Sun due to solar wind pressure. But 3I Atlas showed an asymmetric coma that seemed to pulse and shift in ways that had astronomers double-checking their equipment. Time-lapse observations revealed that the coma wasn't expanding uniformly. Instead, it showed what appeared to be directed jets or plumes, but not in the patterns typically seen from rotating comet nuclei. It was as if the object was venting material in specific directions, almost like controlled releases rather than natural sublimation. But all of these anomalies, the composition, the color, the unusual coma dynamics, paled in comparison to what came next. Because when astronomers started calculating the object's mass based on its observed properties, that's when things went from strange to absolutely mind-boggling. The mass revelation in astronomy. Determining the mass of a distant object is like solving a cosmic puzzle with half the pieces missing. You can't just put a comet on a scale. Instead, you have to infer its mass from indirect observations, how it moves, how much material it's shedding, how it responds to various forces. The first attempts to estimate 3I Atlas's mass used standard cometry models. Based on the brightness and the amount of material being ejected, initial calculations suggested a nucleus perhaps 5 to 6 kilometers across. Large for a comet, but not unprecedented. Comet Hale-Bopp, which dazzled observers in 1997, had a nucleus estimated at 40 to 80 kilometers across. But then astronomers noticed something odd. The object was experiencing what's called non-gravitational acceleration. In simple terms, it wasn't moving exactly as it should if gravity were the only force acting on it. This isn't unusual for comets. The jets of gas and dust act like tiny rocket engines, pushing the comet slightly off its expected path. What was unusual was the magnitude of this acceleration. Dr. James Patterson from MIT was part of the team analyzing the orbital dynamics. In a paper submitted to the Astronomical Journal in late August 2025, his team wrote, "The observed non-gravitational acceleration of 3I Atlas requires either an extraordinarily high mass loss rate or a significantly larger mass than previously estimated. Both possibilities challenge our current understanding of cometary physics." Enter Dr. Avi Loeb. Now, if you follow space news, you know that name. Avi Loeb is the former chair of Harvard's astronomy department and perhaps the most prominent and controversial voice in the search for extraterrestrial intelligence. He's the scientist who suggested Oumuamua might be an alien light sail. He's the one who organized expeditions to recover what might be interstellar meteorite fragments from the ocean floor. Love him or hate him, when Avi Loeb publishes a paper, people pay attention. And in late September 2025, just days ago as we're recording this, Loeb and his team dropped what might be the most shocking paper of his career. The title was innocuous enough. Anomalous Properties of Interstellar Object 3I Atlas, a Comprehensive Analysis. But the contents, pure dynamite. Using a combination of observations from multiple telescopes and sophisticated modeling techniques, Loeb's team calculated that to explain all the observed properties of 3I Atlas, its non-gravitational acceleration, its outgassing rate, its apparent size, the object would need to have a minimum mass of 33 billion tons. I need you to understand what this number means. It's not just big, it's impossibly big for what this object appears to be. Consider Halley's Comet, perhaps the most famous comet in human history. It has an estimated mass of about 242 billion tons, but it's also much, much larger than 3I Atlas appears to be, with a nucleus roughly 15 kilometers long and 8 kilometers wide. If 3I Atlas really has a nucleus only 5 to 6 kilometers across, as optical observations suggest, then having a mass of 33 billion tons would mean it's incredibly, impossibly dense. We're talking about a density approaching that of solid rock or even metal, not the fluffy, porous ice mixture that comets are supposed to be made of. It would be like finding out that what you thought was a cotton ball actually weighs as much as a bowling ball. It simply doesn't make sense within our current understanding of how comets form and what they're made of. The implications begin to unfold. The publication of Loeb's paper sent shockwaves through the astronomical community. Within hours, astronomy Twitter, or X as it's now called, was ablaze with discussions, debates, and no small amount of skepticism. Professional astronomers who usually maintain a dignified academic distance were openly expressing their disbelief. Dr. Patricia Wong from the Carnegie Institution tweeted, "Either we're witnessing the most unusual natural object ever detected, or our models need serious revision. There's no middle ground here." But Loeb's paper went further than just presenting the mass anomaly. In a section that would prove to be the most controversial, he laid out several possible explanations for the observed properties of 3I Atlas, ranging from the mundane to the extraordinary. The first possibility, measurement error. Perhaps the observations were flawed, the instruments miscalibrated, or the analysis techniques inappropriate for such an unusual object. This is always the first thing scientists consider when faced with anomalous data. As the saying goes, extraordinary claims require extraordinary evidence, and the first step is always to make sure your evidence is rock solid. But Loeb's team had been thorough. They'd cross-checked their observations with multiple independent telescopes. They'd used different analysis techniques and arrived at similar results. They'd even gone back and reanalyzed archival data from the object's discovery to make sure nothing had been missed. The measurements seemed solid. The second possibility, 3I Atlas is a completely new class of astronomical object. Perhaps it formed under conditions utterly unlike anything in our solar system. Maybe in its home system, wherever that might be, the protoplanetary disk had a completely different composition, leading to the formation of ultra-dense, CO2-rich comets. It's possible, but it would require rewriting significant portions of our planetary formation theories. The third possibility, and this is where things get really interesting, is that 3I Atlas isn't entirely natural. Now, before you roll your eyes and click away, hear me out. Loeb isn't some crackpot posting videos from his basement. He's a tenured professor at Harvard with over 800 published papers and numerous awards for his contributions to astrophysics. When he suggests something might be artificial, he does so with careful reasoning and mathematical rigor. In his paper, Loeb points out several factors that, taken together, paint a picture that's difficult to reconcile with a natural origin. The extreme mass density, orders of magnitude higher than any known comet. The unusual composition, dominated by CO2 rather than water ice. The asymmetric outgassing patterns that seem almost directed rather than random. The trajectory, which while not impossible for a natural object, does bring it remarkably close to Mars's orbit at just the right time for optimal observation from Earth. Let's talk about what makes a comet a comet. I know that might sound basic, but understanding what we expect from a normal comet is crucial to grasping just how bizarre 3I Atlas really is. Picture a dirty snowball. That's the classic analogy astronomers use. A comet nucleus is essentially a loosely held together mixture of ice, dust, and rocky material, formed in the cold outer reaches of a solar system, where temperatures are low enough for volatile compounds to freeze solid. When a comet approaches its parent star, the ice begins to sublimate, turning directly from solid to gas, creating the spectacular coma and tail we associate with comets. The key word here is loosely. Comet nuclei are typically about as dense as loosely packed snow. Imagine taking fresh powder from a ski slope and gently packing it into a ball. That's the kind of density we're talking about. Maybe 0.6 grams per cubic centimeter, often even less. Some comets are so fragile that they literally fall apart when they get too close to the sun, like Comet Ison did back in 2013. But 3I Atlas. If Loeb's mass calculations are correct, we're looking at a density of at least 8 grams per cubic centimeter, denser than iron, approaching the density of nickel or copper. That's not a snowball, that's a cannonball. Dr. Rebecca Martinez from Caltech's Division of Planetary Sciences put it bluntly in a recent podcast. If these numbers are right, we're not looking at a comet, we're looking at something masquerading as a comet. The outgassing enigma. But the density problem is just one piece of this cosmic puzzle. Let's examine the outgassing behavior more closely, because this is where things get genuinely weird. When the European Southern Observatory's Very Large Telescope, and yes, that's actually what it's called, trained its sophisticated spectrographs 3I Atlas in early August 2025, they expected to see a typical cometary spectrum. What they got instead had astronomers checking and rechecking their instruments. The object was venting carbon dioxide at a prodigious rate. We mentioned those 70 kilograms per second earlier. But here's what's strange. The outgassing wasn't following the pattern we'd expect from solar heating. Normally, as a comet rotates, different areas of its surface are exposed to sunlight, creating a predictable pattern of gas release. The jets should strengthen when facing the sun and weaken when facing away. Atlas wasn't playing by those rules. Dr. Yuki Tanaka from the Japanese Space Agency, JAXA, led a study using multiple ground-based telescopes to observe the object continuously over a 72-hour period. What they found defied conventional explanation. The outgassing showed what Tanaka described as discontinuous periodic variations. In layman's terms, it would gas strongly for a few hours, then almost stop, then resume, but not in any pattern that correlated with the object's rotation or its orientation to the sun. It's almost as if, Tanaka wrote in his preliminary report, the outgassing is being controlled by some internal mechanism, rather than simple solar heating. Now that's a loaded statement. Controlled implies intention, purpose, design, and while Tanaka was careful to note that natural explanations were still possible, perhaps internal pressure buildups, or unusual ice compositions with different sublimation points, the seed of doubt had been planted. The carbon dioxide itself presents another mystery. In our solar system, CO2 ice is relatively rare. It exists mainly in the polar caps of Mars and in some of the colder regions of the outer solar system. For a comet to be dominated by CO2 rather than water ice suggests formation in an environment very different from our own solar system's early days. Dr. Alan Fisher from Oxford's Department of Astrophysics ran computer simulations of protoplanetary disks with various compositions. His conclusion? To get a comet that's predominantly CO2, you'd need formation temperatures below 78 degrees and a protoplanetary disk almost entirely depleted of water. It's possible, but it requires very specific and unusual conditions. Trajectory, anomalies and impossible coincidences now. Let's talk about where this thing is going, because the trajectory of 3I Atlas is another chapter in this book of anomalies. When astronomers first calculated its path, they noticed it would pass remarkably close to Mars, within about 7 million kilometers, or roughly 4.3 million miles. That might sound like a lot, but in cosmic terms, it's a hair's breadth. For perspective, that's about 18 times the distance from Earth to the Moon, close enough that Mars's gravity will noticeably affect the object's trajectory. But here's where it gets interesting. Dr. Jennifer Adams from NASA's Jet Propulsion Laboratory ran what's called a Monte Carlo simulation, essentially calculating thousands of possible trajectories based on slight variations in the initial observations. What she found was statistically fascinating. The probability, Adams reported in a NASA bulletin, of a random interstellar object passing this close to Mars is approximately 1 in 10,000 when you factor in the timing, arriving just when Mars is optimally positioned for observation from Earth. The odds drop to about 1 in 100,000. Now, those might still seem like reasonable odds. After all, unlikely things happen all the time in the universe. But remember, this is only the third interstellar object we've ever detected. To have one of them thread the needle so precisely is, at minimum, remarkably fortuitous. Loeb's paper takes this analysis further. He points out that the trajectory of 3I Atlas, when traced backward, appears to originate from the general direction of Vega, one of the brightest stars in our night sky, located about 25 light-years away. Vega is an interesting star. It's about twice the mass of our Sun and much younger, only about 455 million years old. It's also known to have a debris disk that could potentially harbor planets. If, Loeb writes, 3I Atlas originated from the Vega system and traveled at its current velocity, it would have been traveling for approximately 200,000 years. This is remarkably recent in cosmic terms. The paper goes on to calculate that if the object were deliberately launched from Vega toward our solar system 200,000 years ago, the launcher would have needed to account for the relative motions of both stars and aim for where our solar system would be, not where it was. The precision required for such a trajectory is, as Loeb puts it, non-trivial but entirely achievable for a sufficiently advanced civilization. Comparing the interstellar visitors to truly appreciate how strange 3I Atlas is, we need to compare it to its predecessors, the only other confirmed interstellar objects we've observed. Oumuamua, discovered in October 2017, was our first confirmed interstellar visitor. It was weird from the start, an elongated, cigar-shaped object tumbling through space, showing no signs of outgassing despite its proximity to the Sun and exhibiting that famous non-gravitational acceleration that sparked so much controversy. It was small, perhaps 100 to 200 meters long, and by the time we spotted it, it was already on its way out of the solar system, giving us precious little time to study it. Loeb famously suggested Oumuamua might be an alien light sail, a thin sheet of material designed to be pushed by stellar radiation. The scientific community largely rejected this hypothesis, but the mystery of Oumuamua remains unsolved to this day. Then came 2I Borisov in 2019. This was more like it, a proper comet with a visible coma and tail, outgassing water and other volatiles just like comets from our own solar system. Sure, its composition was slightly different, with more carbon monoxide than typical, but nothing that couldn't be explained by formation in a different stellar environment. Borisov was the normal interstellar visitor that made everyone breathe a sigh of relief. See? Not everything from outside our solar system is weird and inexplicable. And then 3I Atlas arrived and threw that comfortable narrative out the window. Let's look at the numbers. Oumuamua, estimated mass of about 1 million tons, size of about 200 meters, no detected outgassing Borisov. Estimated mass of about 1 billion tons, nucleus size of 0.51 kilometer, normal cometary outgassing 3I Atlas, estimated mass of over 33 billion tons, nucleus size of 5 to 6 kilometers, or up to 46 km if less dense. Anomalous CO2 outgassing. The progression is interesting, isn't it? Each interstellar visitor has been more massive than the last, but 3I Atlas takes it to an absurd extreme. It's not just bigger, it's orders of magnitude more massive than it should be based on its observed size. Dr. Samuel Roberts from the SETI Institute. Yes, the organization dedicated to searching for extraterrestrial intelligence, published a thought-provoking blog post about this progression. If we were to detect a fourth interstellar object that was even more massive and anomalous than 3I Atlas, he wrote, at what point do we stop calling it coincidence and start considering that we might be looking at a pattern? The spectroscopic smoking gun. Let's dive deeper into the spectroscopy, because this is where the hard science lives. When light from the sun reflects off or passes through the coma of 3I Atlas, certain wavelengths are absorbed or emitted by the molecules present. This creates a spectral fingerprint that tells us exactly what chemicals are present. The team at the Keck Observatory in Hawaii, using their high-resolution Echelle spectrometer, detected something unprecedented in late August 2025. Mixed in with the strong CO2 signatures were traces of complex organic molecules, long-chain hydrocarbons, that typically only form under very specific conditions. Dr. Maria Gonzalez, a specialist in astrochemistry at the Max Planck Institute, analyzed these signatures. Her findings, published in a rapid communication to astronomy and astrophysics, were startling. We're detecting methylacetylene and benzene derivatives that suggest processing by high-energy radiation over extended periods. But here's the anomaly. These molecules are uniformly distributed throughout the coma, not concentrated near the nucleus as we'd expect from surface sublimation. Think about what that means. If these complex organics were on the surface of the nucleus, being released as the ice sublimated, they should be most concentrated close to the nucleus and dilute as they spread through the coma. Instead, they're everywhere in equal concentrations. It's as if they're being generated throughout the coma itself, or being released from inside the nucleus through the gas jets in a way that ensures even distribution. Gonzalez offered several possible explanations, each more exotic than the last. Perhaps the nucleus has a porous structure that allows even mixing. Perhaps there are chemical reactions happening in the coma itself, catalyzed by solar radiation. Or perhaps, and this is where she ventures into speculation, the distribution is being actively managed somehow. I want to be clear, Gonzalez stated in a follow-up interview with Scientific American. I'm not suggesting alien intervention, but I am saying that the chemistry we're seeing doesn't match any natural process we currently understand. The response from NASA and ESA, visual NASA and ESA logos, official statement documents. As the anomalies piled up and speculation ran wild, the world's space agencies felt compelled to respond. In mid-September 2025, NASA and the European Space Agency held a joint press conference to address the mounting questions about 3I Atlas. Dr. Thomas Mitchell, NASA's Associate Administrator for Science, struck a measured tone. While the observations of 3I Atlas are certainly intriguing and challenge some of our assumptions about interstellar objects, we must remember that the universe is full of surprises. Every decade, we discover something that forces us to revise our textbooks. That's not a bug in science. It's a feature. The agencies announced a coordinated observation campaign, mobilizing every available asset to study 3I Atlas during its passage through the inner solar system. This included continuous monitoring by the James Webb Space Telescope when possible dedicated, observation time on the Hubble Space Telescope ground-based, observations from telescopes on 6 continents radio, telescope observations to detect any emissions, even an attempt to bounce radar signals off the object using the Arecibo successor facility in China sound effect. Radio telescope sounds. Dr. Isabella Rossi from ESA was more direct about addressing the elephant in the room. Yes, we've heard the speculation about artificial origin. While we can't rule anything out completely, we want to emphasize that natural explanations remain the most likely. The universe is stranger than we imagine, but that doesn't mean we need to invoke extraterrestrial intelligence every time we see something unusual. But privately, sources within both agencies painted a different picture. A leaked email from a senior NASA scientist, published by Futurism, revealed the level of concern. We need to be prepared for any possibility. If this thing shows any sign of controlled behavior, any sign at all, we need protocols in place. The academic battle lines are drawn, though. Publication of Loeb's paper sparked what can only be described as an academic civil war within the astronomical community. On one side were those who felt Loeb was being irresponsible, jumping to extraordinary conclusions without extraordinary evidence. On the other were those who argued that dismissing unusual observations simply because they didn't fit existing models was equally unscientific. Dr. Richard Thompson from Princeton's Department of Astrophysical Sciences led the charge against Loeb's interpretations. In a scathing response paper uploaded to Archive, Thompson and 12 co-authors presented alternative calculations, suggesting the mass estimates might be off by an order of magnitude. The non-gravitational acceleration, Thompson argued, could be explained by asymmetric outgassing from a rotating nucleus with an unusual shape. If the nucleus is highly elongated, like Oumuamua, and the active regions are concentrated at the ends, you could get the observed acceleration with a much lower mass. Thompson's team proposed that 3I Atlas might have a nucleus shaped like a dumbbell, or even a contact binary, 2 objects loosely held together by gravity. This could explain both the unusual outgassing patterns and the apparent mass anomaly. But Loeb fired back quickly. In a response posted on Medium and later submitted as a formal rebuttal, he pointed out several flaws in Thompson's analysis. The proposed elongated shape would be visible in high-resolution imaging, which shows no such structure. Furthermore, the spectroscopic data is inconsistent with exposed surface area, varying due to rotation. The CO2 emission remains constant regardless of viewing angle, suggesting either a spherical source or controlled emission. The debate spilled onto social media, with astronomers taking sides and the public watching in fascination. The hashtag #Atlas debate trended for 3 days straight, with everyone from amateur astronomers to science fiction authors weighing in. Dr. Lisa Park from Stanford tried to find middle ground. Both sides make valid points. The truth is, we're dealing with incomplete data about an object unlike anything we've seen before. Instead of fighting about interpretations, we should focus on getting better observations. The Mars Close Approach looms. As September 2025 drew to a close, all eyes turned to the upcoming Close Approach to Mars, scheduled for October 15th. This would be the closest 3I Atlas would come to any major body in our solar system, and it presented a unique opportunity. Mars has an armada of scientific instruments in orbit around it. NASA's Mars Reconnaissance Orbiter, MAVEN, the European Mars Express, the Indian Mars Orbiter Mission 2, and the Chinese Tianwen-1. While these instruments were designed to study Mars, not passing comets, their proximity to 3I Atlas during the flyby would allow for observations impossible from Earth. Dr. James Liu from the Mars Exploration Program outlined the observation plan. We're going to get our closest look yet. MRO's high-rise camera might actually be able to resolve the nucleus directly. MAVEN's spectrometers will sample the Comet as it passes. We might finally get answers to some of these mysteries. But there was another possibility that had people both excited and nervous. If 3I Atlas showed any reaction to Mars, any change in trajectory beyond what gravity would cause, any change in outgassing, any response at all, it would be the strongest indication yet that this object was more than just a weird comet. The stage was set for what could be the most important astronomical observation in human history. In just 2 weeks, 3I Atlas would sweep past Mars, and every telescope, every spectrometer, every camera we could muster would be watching. The wild card: amateur astronomers. While the professionals debated and the space agencies mobilized, an army of amateur astronomers around the world turned their equipment toward 3I Atlas, and it was an amateur who made the next shocking discovery. Robert Kelly, a retired engineer from Arizona with a passion for astronomy and a backyard observatory that would make some universities jealous, had been imaging 3I Atlas every clear night since its discovery. He developed his own image processing techniques over years of comet hunting, and on the night of September 23, 2025, he noticed something odd. "I was stacking images to bring out faint details," Kelly explained in a YouTube video that would eventually rack up 12 million views, "when I saw what looked like a symmetric structure in the coma, not random jets, symmetric, like spokes on a wheel." At first, the professional community dismissed it as an image processing artifact, but then other amateurs started reporting the same thing. Using different equipment, different techniques, from different locations around the globe, they were all seeing the same spoke-like pattern in the coma of 3I Atlas. Dr. Amanda Foster from the American Association of Variable Star Observers, which coordinates amateur observations, compiled the reports. "We have 17 independent confirmations of the spoke pattern. Whatever it is, it's real." The spokes appeared to rotate with a period of about 17.6 hours. But here's the kicker: that didn't match any rotation period calculated for the nucleus based on brightness variations. It was as if the coma and the nucleus were rotating independently, which should be physically impossible for a natural comet. Theories flew thick and fast. Maybe it was an interaction with the solar wind creating standing waves in the coma. Maybe it was magnetic field effects from charged particles. Maybe it was an optical illusion caused by the viewing angle from Earth. Or maybe, just maybe, it was something else entirely. October 15th, 2025. Mark that date in your calendars, folks, because it might just be the day everything changed. As dawn broke over NASA's Jet Propulsion Laboratory in Pasadena, California, the atmosphere was electric. Scientists who'd pulled all-nighters fueled by coffee and adrenaline crowded around monitors displaying telemetry from Mars orbit. The countdown clock on the wall showed T-3 hours until 3I Atlas made its closest approach to the red planet. Dr. Jennifer Walsh, mission director for the Coordinated Observation Campaign, later described the scene. "I've been in mission control for 7 Mars landings, but I've never felt tension like this. We all knew we were about to witness something unprecedented. The question was, would it confirm our understanding of comets, or shatter it completely?" The plan was ambitious. Every available instrument in Mars orbit had been programmed to observe 3I Atlas during its passage. The Mars Reconnaissance Orbiter would attempt to image the nucleus directly. MAVEN would fly through the tail of the coma, if orbital mechanics allowed, sampling its composition firsthand. The Chinese Tianwen-1 would use its radar to probe the object's interior structure. But as 3I Atlas approached Mars, the first signs that this wouldn't be a routine observation came from an unexpected source: the magnetic anomaly MAVEN, the Mars atmosphere, and volatile. Evolution spacecraft has a magnetometer designed to study Mars's weak magnetic field. At T-47 minutes, it detected something extraordinary. Dr. Bruce Jakosky, MAVEN's principal investigator, was watching the data live. The magnetic field readings went crazy. We saw organized magnetic structures approaching Mars, not the chaotic fields you'd expect from a comet's ionized gas, but organized, almost like... He paused in his later testimony to Congress, choosing his words carefully, like a magnetic bubble around the object, as if 3I Atlas was carrying its own magnetosphere. Now, let me explain why this is absolutely mind-blowing. Comets can generate weak magnetic fields through their interaction with the solar wind, charged particles from the sun hitting the ionized gas in the coma. But these fields are diffuse, chaotic, constantly changing. What MAVEN detected was stable, organized, and orders of magnitude stronger than any comet should produce. The magnetic field extended roughly 50,000 kilometers from the object, about 4 times Earth's diameter. It was roughly dipolar, like a giant bar magnet, but with peculiar asymmetries that suggested a complex internal structure. Dr. Margaret Chen from the Space Weather Prediction Center ran the numbers. To generate a field this strong, you'd need either a massive metallic core with residual magnetism or an active power source. Natural comets have neither. The images that changed everything at T-12 minutes. The Mars Reconnaissance Orbiter's HiRISE camera, the most powerful camera ever sent to another planet, turned toward 3I Atlas. HiRISE can resolve objects as small as a coffee table from Mars orbit. Pointed at 3I Atlas from just 7 million kilometers away, it should have been able to see details as small as 150 meters across. The first images were transmitted to Earth at T+8 minutes, accounting for the speed of light delay from Mars. When they appeared on the screens at JPL, the room fell absolutely silent. Dr. Alfred McEwen, HiRISE principal investigator, described what they saw. It wasn't what we expected. Not at all. Instead of an irregular potato-shaped chunk of ice and rock, the typical comet nucleus, HiRISE revealed something else. The object appeared to have structure, not random, natural structure like mountains and valleys, but geometric structure. The clearest image showed what appeared to be a cylindrical central body, approximately 5.7 kilometers long and 1.2 kilometers in diameter. But attached to this cylinder were what looked like 3 equidistant projections or panels, each extending about 2 kilometers from the central body. The entire structure was rotating slowly, which explained the spoke pattern amateur astronomers had detected in the coma. My first thought, admitted Dr. McEwen, was that we were seeing some kind of imaging artifact, maybe ice crystals on our lens or a calibration error. But multiple images showed the same structure from slightly different angles as the object rotated. It was real. The room erupted. Scientists were shouting, some in excitement, others in disbelief. Dr. Walsh had to call for order 3 times before the chaos subsided enough for work to continue. Within hours, the images had leaked. Despite NASA's attempts at information control, someone, we still don't know who, posted them on Reddit. Within 6 hours, they were the top story on every news outlet on Earth. The telemetry anomaly. But the visual revelations were just the beginning. As 3I Atlas passed closest to Mars, something happened that wasn't in anyone's predictions. Every spacecraft in Mars orbit experienced simultaneous telemetry glitches. Not failures, glitches, for exactly 73 seconds. Their transmissions to Earth contained embedded patterns that weren't part of their normal data streams. Sound effect, digital interference, then strange harmonic pattern. Dr. Shannon Peters from the Deep Space Network described it. It was like someone was using our spacecraft as transmitters. The carrier waves were modulated with a signal we didn't generate. The pattern was complex, definitely not random noise. The signal, when analyzed, showed mathematical properties. It contained prime number sequences, Fibonacci ratios, and what appeared to be a base 8 counting system. Cryptographers and mathematicians worldwide pored over the data, looking for meaning. Dr. Carl Matthews from MIT's Computer Science and Artificial Intelligence Laboratory made the first breakthrough. The signal appears to be a kind of handshake protocol, a way of establishing communication. It's broadcasting mathematical constants that any technological civilization would recognize, almost like it's saying, we know you're listening, and we know you're intelligent enough to understand this. Let that sink in. The object appeared to use our own spacecraft to send us a message. That's not something a comet does. That's not something any natural object does. Loeb's vindication and new revelations back at Harvard. Avi Loeb watched the Mars encounter unfold with what colleagues described as grim satisfaction. He'd been saying for months that 3I Atlas was anomalous. Now, the evidence was overwhelming. Within 24 hours of the Mars encounter, Loeb published a new paper, this one not going through the usual peer review process, but posted directly to Archive for immediate dissemination. The title was provocative. 3I Atlas, first confirmed observation of non-human technology in our solar system. The paper was comprehensive, pulling together all the anomalous observations, the impossible, density suggesting artificial construction, materials, the controlled outgassing patterns suggesting propulsion rather than sublimation, the geometric structure revealed by HiRISE, the artificial magnetosphere, the encoded signal transmitted through our Mars orbiters, the precise trajectory that brought it close to Mars and Earth's observation capabilities. But Loeb went further. He proposed that 3I Atlas wasn't just a piece of alien technology, it was active alien technology, possibly a probe sent to study our solar system. The object's trajectory, Loeb wrote, brings it close to Mars, where we have multiple observation platforms, at precisely the time when our civilization has the capability to detect and analyze it. This is either an extraordinary coincidence or deliberate timing. He calculated the odds. Given the vastness of space and time, the probability of a random alien artifact passing through our solar system, just as we develop the technology to detect it, is infinitesimally small. Unless, of course, it's not random. The world reacts. The Mars encounter images and data hit the public like a thunderbolt. Within hours, every major news outlet on Earth was running wall-to-wall coverage. The headlines range from sensational to terrified. First contact? CNN alien probe passes Mars. BBC. We are not alone. The New York Times. Humanity's greatest discovery. The Guardian. The day everything changed. Le Monde. Social media exploded. Alien probe and MUF 3 Atlas trended globally. Religious leaders called for calm, while privately grappling with theological implications. Stock markets plunged, then surged, then plunged again, as investors tried to process what this meant for humanity's future. Dr. Patricia Williams, a sociologist at Oxford who studies public reaction to potential extraterrestrial contact, observed, "We're seeing every possible human reaction simultaneously. Fear, wonder, skepticism, denial, acceptance, even worship. Some people are treating this as vindication of their beliefs, others as an existential threat." Emergency sessions were called at the United Nations. The UN Office for Outer Space Affairs, typically a sleepy bureaucratic backwater, suddenly found itself at the center of the greatest diplomatic challenge in human history. Ambassador Chen Wei, speaking at an Emergency Security Council session, put it starkly: "We must proceed on the assumption that we are being observed by an intelligence capable of crossing interstellar space. Our response will define humanity's future." The scientific pushback, not everyone was convinced. A significant portion of the scientific community pushed back hard against the alien technology hypothesis, proposing alternative explanations for each anomaly. Dr. Michael Harrison from Caltech led the skeptics. "We're seeing what we want to see. The high-rise images are low resolution and ambiguous. The geometric structure could be natural crystalline formations. The magnetic field could be from metallic inclusions. The signal could be instrument malfunction or interference." A group of 147 scientists signed an open letter urging caution. Extraordinary claims require extraordinary evidence. While the observations of 3I Atlas are certainly unusual, jumping to conclusions about alien technology is premature and potentially dangerous. We call for continued observation and analysis before making any definitive claims. Dr. Sandra Mitchell from the SETI Institute, surprisingly, sided with the skeptics. "I've spent my entire career looking for signs of extraterrestrial intelligence. Believe me, I want this to be real. But we've been fooled before. Remember the face on Mars? Pulsars being mistaken for alien beacons. We need to be absolutely certain before we tell the world we've found alien technology." But others pointed out that the skeptics were struggling to explain all the anomalies with a single natural mechanism. Dr. James Foster from Cambridge noted, "Yes, each individual anomaly might have a natural explanation. But what's the probability that all of these unusual features would occur in the same object by chance?" At some point, Occam's razor suggests the simpler explanation is that it's artificial. The second transmission. October 18th, 3 days after the Mars encounter, radio telescopes detected something. The signal was detected simultaneously by the Very Large Array in New Mexico, the Arecibo successor in China, and the Square Kilometre Array in Australia. This wasn't scattered radiation or natural emission. It was a focused, directed transmission at a specific frequency. 1420 MHz, the hydrogen line, considered the universal frequency for interstellar communication. Dr. Elizabeth Turner from the Allen Telescope Array described the moment of discovery. My blood ran cold. We've been listening for signals at 1420 MHz for decades, hoping to hear from extraterrestrial intelligence. And now, something in our own solar system was broadcasting at exactly that frequency, aimed directly at us. The signal was complex, structured in packets that repeated every 11.3 seconds. When decoded, it revealed something astonishing: images. The first image was a schematic of our solar system, with the positions of all planets marked accurately as of October 18, 2025. The second showed 3I Atlas's trajectory through our system. The third was a diagram of hydrogen, helium, and carbon atoms, the building blocks of organic chemistry. But the fourth image was the one that caused gasps in control rooms worldwide. It appeared to show the internal structure of 3I Atlas itself. The diagram revealed a complex interior with distinct chambers and what appeared to be a central core surrounded by concentric shells. Labels in an unknown but clearly artificial symbol system marked different sections. Some scientists interpreted certain sections as propulsion systems, others as sensors or communication arrays. Dr. Robert Chen, a specialist in xenolinguistics, yes, that's a real field, at UCLA, analyzed the symbols. They're definitely artificial, showing consistent patterns and what appears to be grammatical structure. This isn't random, it's language. We're being shown a blueprint. The Chinese revelation. On October 20th, the China National Space Administration, CNSA, dropped their own bombshell. They revealed that their Tianwen-1 orbiter had deployed a small CubeSat during the Mars encounter specifically to get closer to 3I Atlas, something they hadn't previously disclosed. The CubeSat, designated Yinghe-1, had passed within 50,000 kilometers of 3I Atlas and taken unprecedented close-up images and readings. The Chinese had kept this secret for 5 days while analyzing the data, but now felt compelled to share with the world. The images from Yinghe-1 were stunning and terrifying in their clarity. They showed surface details of 3I Atlas at a resolution of just 10 meters per pixel. The surface wasn't ice or rock. It appeared to be a manufactured material with a regular hexagonal pattern, like enormous tiles or panels. Some panels were dark, others reflected sunlight with mirror-like perfection. Some appeared to be opening and closing, revealing glimpses of illuminated interiors. But most shocking was what Yinghe-1 detected with its spectrometer. The material composition of 3I Atlas's surface included elements and ratios that don't occur naturally. Specifically, isotopes of titanium and vanadium in proportions that suggested deliberate engineering rather than natural formation. General Liu Wei, speaking for the CNSA, stated, "Based on our observations, we conclude with high confidence that 3I Atlas is an artificial construct. We believe humanity must unite in response to this reality." The Chinese announcement changed everything. This wasn't just Avi Loeb and a handful of scientists making extraordinary claims. This was a major world power officially stating that we were dealing with alien technology. Decoding the message is. October turned to November. The world's best cryptographers, linguists, and computer scientists worked around the clock to decode more of the transmissions from 3I Atlas. The object continued to broadcast, sending new image packets every few hours. A breakthrough came from an unexpected source. Dr. Sarah Kim, a musicologist from Juilliard, noticed that the timing of the transmissions followed mathematical ratios found in musical harmony. It's using the mathematics of music, octaves, perfect fifths, major thirds. These are ratios that any species with hearing would likely discover. Using this insight, teams managed to decode what appeared to be a primer, a teaching document showing how to interpret the rest of the message. It started with basic mathematics, then chemistry, then physics, building a common language of science. Dr. Michael Torres from IBM's Watson AI team fed the primer into their most advanced machine learning systems. Within 72 hours, the AI had decoded enough to reveal a shocking message. Greetings, we are messengers. We carry information from multiple origins. Your development is noted. Your readiness is assessed. Prepare for expanded contact. The message continued with coordinates, not in space, but in time. A date, December 21st, 2025, the winter solstice, and a location, the L5 Lagrange point, a gravitationally stable position in Earth's orbit where objects can maintain a fixed, position relative to Earth and the Sun, the implication was clear. 3i Atlas was announcing a rendezvous, the philosophical earthquake, while scientists and governments grappled with the practical implications. Philosophers, theologians, and thinkers worldwide struggled with the existential ramifications. Dr. Jennifer Martinez, professor of philosophy at Harvard, wrote in a hastily published essay, "In a single moment, humanity has gone from possibly alone in the universe to definitely not alone. Every assumption about our uniqueness, our purpose, our future, must now be reconsidered." The Vatican called an unprecedented council, bringing together not just Catholic theologians, but representatives from every major religion. The Dalai Lama spoke of universal consciousness, transcending planetary boundaries. Islamic scholars debated whether intelligence from other worlds was mentioned in the Quran. Hindu philosophers noted that their cosmology had always included multiple worlds and beings. Dr. Richard Davies, an atheist philosopher from Oxford, noted ironically, "The discovery of alien intelligence might be the one thing that finally unites humanity's religions. They'll all have to figure out how to incorporate this into their worldviews." But beyond religion, fundamental questions arose. If 3i Atlas was a messenger, who sent it? Why now? What did multiple origins mean? Were we dealing with a federation of civilizations? And most pressingly, what should humanity's response be? Preparing for contact, governments worldwide went into overdrive. The UN Security Council passed Resolution 2847, creating the Committee for Extraterrestrial Contact, with representatives from every nation. Their mandate: prepare humanity's response to the December 21st rendezvous. The military implications couldn't be ignored. While 3i Atlas hadn't shown any hostile intent, its capabilities, crossing interstellar space, generating massive magnetic fields, transmitting signals that could override our technology, suggested a level of advancement that made Earth's defenses meaningless. General Patricia Thompson, chairman of the Joint Chiefs of Staff, testified before Congress, "If this intelligence wanted to harm us, we would have no defense. Our only strategy can be peaceful engagement and hope that their intentions are benign." Meanwhile, scientists worked on preparing our own message. What should humanity say to an alien intelligence? Teams of linguists, mathematicians, artists, and musicians collaborated to create a response that would represent all of humanity. Our achievements, our culture, our hopes, and our peaceful intentions. Dr. Ann Druyan, who had worked on the Voyager Golden Record decades earlier, was brought out of retirement to consult. With Voyager, we were putting a message in a bottle, hoping someone might find it someday. Now, we're writing a letter to someone we know is listening. The pressure is indescribable. The trajectory changes on November 3rd, 2025. 3i Atlas did something that removed any lingering doubt about its artificial nature. It changed course. Not slightly, not gradually. The object executed a 17-degree turn over the course of just 6 hours, a maneuver that would require enormous energy and was physically impossible for a natural comet. The new trajectory would bring it to the L5 Lagrange point on exactly December 21st, just as the message had indicated. Dr. Robert Anderson from JPL ran the calculations. The energy required for this maneuver is equivalent to several nuclear weapons. The fact that we detected no visible propulsion, no rocket exhaust, no reaction mass, suggests a propulsion technology beyond our current understanding, possibly a reactionless drive that would revolutionize physics as we know it. The trajectory change was observed by telescopes worldwide and by millions of amateur astronomers. There was no denying it, no explaining it away. 3i Atlas was actively navigating, heading for a rendezvous with Earth. December 21st, 2025. The winter solstice, the shortest day of the year in the northern hemisphere, when ancient humans once believed the barrier between worlds grew thin. How appropriate that this would be the day chosen for humanity's first scheduled meeting with an intelligence from beyond Earth. In the 6 weeks since 3i Atlas changed course, the world had transformed in ways both profound and practical. The stock markets had stabilized, but only after the largest restructuring in history. Companies focused on space technology saw their valuations skyrocket. Defense contractors pivoted to xenotechnology. Research. The entire fossil fuel industry collapsed virtually overnight as investors realized that any civilization capable of interstellar travel must have solved the energy problem. But it was the human changes that were most remarkable. Crime rates plummeted globally. Wars paused, then ended, as combatants realized how pointless their conflicts seemed in the face of this cosmic revelation. Church attendance surged, then evolved, as congregations gathered not just to pray, but to discuss, to process, to find meaning in this new reality. Dr. Marcus Thompson, a sociologist at MIT, documented what he called the Great Sobering. Humanity collectively realized we were about to be judged by an intelligence that could cross the stars. Every person, every nation asked themselves, how do we want to be remembered? How do we want to represent our species? The result was the most rapid social transformation in human history. The final approaches. December progressed. 3I Atlas continued its impossible approach to the L5 Lagrange point. The object had stopped outgassing completely on December 1st, shedding its cometary disguise like a butterfly emerging from a chrysalis. Without the obscuring coma, telescopes could now see it clearly. The structure was even more complex than the high-rise images had suggested. The central cylinder was revealed to be segmented, with each section capable of rotating independently. The three projections weren't static panels, but articulated structures that moved with purpose, occasionally catching sunlight in ways that created dazzling displays visible even to small telescopes on Earth. Dr. Elena Vasquez from the European Southern Observatory spent sleepless nights analyzing the object's surface. We're seeing what appear to be apertures opening and closing, antennae extending and retracting, surfaces that shift from absorbing all light to reflecting it perfectly. It's as if the object is preparing itself. On December 15th, a new development. 3I Atlas began broadcasting on multiple frequencies simultaneously. Not messages this time, but carrier waves, pure tones at precise mathematical intervals. Dr. James Chen from SETI recognized the pattern immediately. It's a beacon. It's making sure we can find it, track it, stay in communication with it. It wants to be observed. The world's most powerful radio telescopes formed an unprecedented coalition, creating a de facto planetary receiver array. The Very Large Array, the Square Kilometre Array, Arecibo's successor, FAST in China, and dozens of smaller installations all synchronized their observations, turning Earth itself into a giant ear, listening to the cosmos. The assembly at L5 every space agency on Earth had mobilized for December 21st. While no human spacecraft could reach L5 in time, every available satellite, telescope and sensor was trained on that point in space. The James Webb Space Telescope had suspended all other observations. The Hubble, despite its age, was pushed to its limits. Even commercial satellites were commandeered for the event. At the United Nations, the Committee for Extraterrestrial Contact convened in continuous session. Representatives from 195 nations, along with indigenous leaders, religious figures, scientists, artists and philosophers, gathered to witness humanity's response to whatever was about to occur. Secretary General Amara Okonkwo addressed the Assembly on the morning of December 21st. Today, we speak not as separate nations but as one species, one voice, reaching out to the cosmos. Whatever happens in the coming hours, humanity will face it together. Around the world, billions gathered to watch. Times Square in New York, Shibuya in Tokyo, Trafalgar Square in London, Red Square in Moscow. Every major public space became an open-air viewing party. The internet strained under the load as half of humanity tried to stream the event simultaneously. NASA's official stream alone had 3.2 billion concurrent viewers, shattering every previous record. Commentary was provided in over 100 languages, with scientists, philosophers, and cultural leaders offering perspectives to help humanity process what they were witnessing. The arrival at 14:33 UTC on December 21st, 2025, 3I Atlas arrived at the L5 Lagrange point and came to a complete stop. Let me repeat that. It stopped. An object that had been traveling at interstellar velocities, that had crossed unimaginable distances, simply stopped. No deceleration burn, no visible propulsion, no reaction mass ejected. It just ceased moving relative to Earth's orbital reference frame, holding position at L5 with impossible precision. Dr. Catherine Phillips from NASA's Jet Propulsion Laboratory was monitoring the telemetry. It's not orbiting, It's not using thrust to maintain position. It's just there, stationary. The physics of what we're seeing should be impossible, yet there it is. For 17 minutes, 3I Atlas hung motionless in space, silent on all frequencies. The world held its breath. Then, at 1450 UTC, it began. The transformation started slowly. The three projections that had remained static during the approach began to unfold. But unfold doesn't do justice to what the world witnessed. They bloomed like mechanical flowers, revealing layer after layer of impossibly complex structures. Each projection extended to nearly 20 kilometers, forming a triangular array around the central cylinder. The structures were fractal in nature. The closer the telescopes zoomed in, the more detail they revealed. Surfaces within surfaces, mechanisms within mechanisms, patterns repeating at every scale. Dr. Roger Penrose, the legendary physicist and mathematician, was providing commentary for the BBC. What we're seeing appears to be a practical application of fractal geometry at a scale we've never imagined. The surface area being revealed is orders of magnitude greater than the apparent volume. It's like it's bigger on the inside than the outside. The extended structures began to glow, not with reflected sunlight, but with their own light. Colors rippled across the surfaces in patterns that seemed almost organic. Blues and greens primarily, but with flashes of gold and violet that hurt to look at directly, as if they were colors just outside human perception. Then came the sound. Of course, sound doesn't travel through the vacuum of space, but every radio receiver on Earth picked up the same transmission. A deep, resonant tone that, when played through speakers, seemed to bypass the ears and resonate directly in listeners' bones. It was felt as much as heard, a vibration that connected every human listening to it. Dr. Sarah Kim, the musicologist who had helped decode earlier transmissions, was in tears. It's music, mathematical music. It's playing the harmonics of hydrogen, the fundamental frequency of the universe itself. The message unfolds at 1507. UTC. The space around 3I Atlas began to shimmer. The telescopes had trouble focusing, as if space itself was being distorted. Then, incredibly, holographic projections appeared in the vacuum, three-dimensional images visible from Earth, somehow projected across 400,000 kilometers of empty space. The first image was Earth itself, rendered in perfect detail, rotating slowly. But this wasn't current Earth. Continents were in slightly different positions. Scientists quickly realized they were seeing Earth from different time periods. The Permian, the Cretaceous, the last ice age, the present, and then the future. Multiple versions of Earth appeared, showing different possible futures. Some showed gleaming cities and green continents. Others showed barren wastelands. One showed Earth with rings like Saturn. Another showed 2 moons in orbit. The message was clear. The future was not fixed. Choices mattered. Then came images of other worlds. Dozens of them. Planets with purple vegetation under binary suns. Ocean worlds with cities beneath the waves. Desert planets with vast solar collectors. Worlds of crystal and metal that were clearly artificial constructs. Each was labeled with symbols that the decoding teams recognized from the earlier primer. These were coordinates, distances, names. Dr. Lisa Park from the Committee for Extraterrestrial Contact gasped in recognition. These aren't just random worlds. Look at the star patterns in the backgrounds. These are our stellar neighbors. Proxima Centauri, Wolf 359, Lalanda 2185. It's showing us inhabited worlds within 20 light-years of Earth. The implications were staggering. We weren't just not alone. We were surrounded by intelligence. The galaxy was teeming with life and civilization. The ambassadors. The projections changed again. Now they showed beings. Not one species, but many. The images were respectful, showing the entities at a distance, allowing humanity to observe without feeling threatened. Some were vaguely humanoid, bipedal with recognizable limbs and sensory organs, though with variations that spoke of evolution under different conditions. Others challenged our concepts of life itself, crystalline beings that seemed to be living mineral structures, gaseous entities that pulsed with internal light, things that looked like organic machines or mechanical organisms. Dr. Ashley Robinson, a xenobiologist from Harvard, provided commentary with awe in her voice. We're seeing convergent evolution on a galactic scale. Some forms are familiar. The efficiency of bilateral symmetry, sensory organs clustered near neural centers. But others show that intelligence can arise in forms we never imagined. One image lingered longer than the others. It showed a being that seemed to be made of light itself, patterns of energy that suggested consciousness without fixed form. When this image appeared, the resonant tone changed, became almost welcoming. Then came the revelation that changed everything. The projections showed a vast network of lines connecting stars throughout the local galactic region. At first, astronomers thought they were seeing trade routes or communication channels. But Dr. Miguel Santos from the Institute for Advanced Study recognized something else. Those aren't just paths between stars. Look at the geometries. They're showing us the structure of something bigger. It's like looking at the neural pathways of a brain. The network pulsed with activity, information, or energy flowing along the connections, and at certain nodes the activity was particularly intense. One of those nodes was now Earth's solar system, glowing brighter as 3I Atlas arrived. The message was breathtaking in its implications. Galactic civilization wasn't just a collection of separate species. It was an integrated network, a collective intelligence spanning light years, and humanity had just been noticed by it. The gift at 1542. UTC 3I Atlas began transmitting again. But this wasn't the simple radio signals from before. This was a focused beam of information directed at Earth, utilizing frequencies and modulation techniques that our receivers could barely process. The data rate was staggering, petabytes per second, more information than humanity had generated in its entire history, flowing from the artifact to our waiting receivers. Supercomputers worldwide strained to store and process the incoming data. Dr. Jennifer Walsh at JPL described the scene. It's like trying to drink from a fire hose. The information is structured, organized, but there's so much of it. We're seeing mathematics, physics, chemistry, biology, but also things we don't have categories for. Initial analysis revealed several distinct sections. First, scientific knowledge. Solutions to mathematical problems humanity had struggled with for centuries. Physics equations that unified quantum mechanics and general relativity. Medical information that showed how to cure diseases that had plagued us forever. Energy production methods that made fusion look primitive. Propulsion technologies that could take us to the stars. Second, historical records. Not our history, theirs. The stories of civilizations rising and falling across the galaxy. Some that destroyed themselves, serving as warnings. Others that transcended physical existence entirely. The records went back millions of years. A galactic memory that dwarfed human experience. Third, philosophical and cultural exchanges. Art forms we had no context for. Music in frequencies we couldn't hear but could somehow feel. Literature that assumed senses we didn't possess, but that somehow conveyed meaning anyway. The diversity of thought and expression from 1,000 different species. And fourth, instructions. Clear, step-by-step guides for building communication devices that could connect to the galactic network. The blueprints were designed to be constructed with Earth's current technology, using materials we had available. It was an invitation to join the conversation. Dr. Chen Wei, speaking for the Committee for Extraterrestrial Contact, made the announcement the world was waiting for. We are being invited to join a galactic community, not as subjects or subordinates, but as a new voice in an ancient conversation. The choice is ours. The choice. At 16 NAS UTC exactly, 3I Atlas powered down its projections. The extended structures began to retract, folding back into the compact form observed during its approach. The transmission of data ceased, though what had already been sent would take decades to fully analyze. But before it went silent, one final message was transmitted, this time in perfect English, Chinese, Hindi, Spanish, and a dozen other Earth languages simultaneously. You have been observed. You show promise. The invitation is extended. Build the beacon when you are ready. We will be listening. And then, as suddenly as it had arrived, 3 Atlas began to move again. Not back the way it came, but onward, toward the outer solar system. Its trajectory would take it past Jupiter, past Saturn, toward the stars once more. But as it departed, it left something behind. A small object, perhaps 10 meters across, separated from the main structure and remained at L5. Telescopic observation revealed it to be a perfect sphere, rotating slowly, emitting a faint blue light. Dr. Avi Loeb, vindicated beyond his wildest dreams, spoke at a Harvard press conference. They've left us a reminder, a marker, perhaps a test. The sphere is there to show that this really happened, that it wasn't a dream or a hallucination, and perhaps to see what we do with it. The aftermath in the days following the rendezvous, the world struggled to process what had occurred. The United Nations General Assembly voted unanimously to create the Office of Galactic Affairs, tasked with coordinating humanity's response to the invitation. The data from 3i Atlas was placed in a public repository, available to every scientist, every student, every curious mind on Earth. Universities created entire departments devoted to xenostudies. Children grew up knowing that the stars weren't empty, but full of potential friends and teachers. Construction began almost immediately on the communication beacon, following the blueprints provided. It would take 2 years to complete, but when activated, it would announce to the galaxy that Earth was ready to join the conversation. Some voices urged caution. What if the network wasn't benign? What if joining meant losing our independence, our unique human character? But these voices were largely drowned out by the excitement and hope that permeated humanity. Dr. Maria Gonzalez, the astrochemist who had first noticed the unusual molecular distributions, reflected on the journey. 6 months ago, we thought we might be alone. Now we know we're part of something infinitely larger. It's terrifying and wonderful in equal measure. The departure and the promise. As 3i Atlas passed Jupiter's orbit in January 2026, it sent one final transmission, not words this time, but music. A symphony that incorporated themes from Earth's radio broadcasts it had apparently been monitoring. Beethoven's Ninth mixed with whale songs, traditional drums from Africa, and something entirely alien but beautiful. The message was clear. They had been listening to us, learning about us, and they found something worth preserving, worth nurturing, worth inviting into the larger community. Dr. Carl Sagan had once said, "The cosmos is within us. We are made of star stuff." Now humanity knew that the cosmos was not just within us, but around us, full of intelligence and wonder, waiting for us to take our place among the stars. Epilogue: the questions that remain us. I record this in late January 2026. 3 months after first contact, questions remain. Who exactly sent 3i Atlas? Was it a single species or truly a collective effort? Why now? Had they been watching us for longer than we knew? Were Oumuamua and Borisov also probes, scouts preparing the way? The sphere at L5 remains a mystery. It responds to no signals, shows no activity beyond its gentle rotation and faint glow. Some believe it's a test. When we're truly ready, we'll know how to activate it. Others think it's a guardian, watching to ensure we use the knowledge wisely. Still others believe it's simply a calling card, proof that we didn't imagine the whole thing. Atlas itself continues its journey out of our solar system. Its current trajectory will take it toward the constellation Sagittarius, toward the center of our galaxy. Is it heading home, or on to the next species ready for contact? As humanity builds its beacon, prepares to announce itself to the galaxy, we stand at the threshold of a new era. The age of cosmic isolation is ending. The age of galactic citizenship is about to begin. The questions now aren't whether we're alone, we know we're not. The questions are, what kind of galactic citizens will we be? What will we contribute to this vast community? How will contact change us? And perhaps most importantly, are we ready? One thing is certain, December 21st, 2025 will forever be remembered as the day everything changed. The day humanity learned that the universe isn't just vast and empty, but vast and full. Full of intelligence, full of possibility, full of promise, and somewhere out there, racing through the cosmos at impossible speeds, 3i Atlas carries news of a young species taking its first steps toward the stars. A species that showed curiosity instead of fear, wonder instead of aggression, hope instead of despair. The universe is watching, and now we're watching back. Thank you for joining me on this incredible journey through one of the most important events in human history. If this video has amazed you as much as the actual events amazed our world, please like, subscribe, and share. The conversation about our place in the universe has only just begun, and I want you to be part of it. What do you think? Are we ready for what comes next? Leave your thoughts in the comments below. And remember, keep watching the skies. You never know what might be watching back.